Hey, everybody, it's May 4th. May the 4th be with you. Oh my God, I said that out loud. May the 4th be with you. It's May 4th, 2022. This is Introduction to Stats at College of Sequoias, Math 21, and we are doing the review for the final. Now, the review for the final will be in Canvas, and there's a practice exam there that is ungraded. I'm not grading it, but it allows you to see what types of questions I'm going to ask, and we're going to walk through some of them today. So this is stats review for final. And you can access it right now. It currently says a date of May 7th is when the practice final is going to be done. It's not me. I need to go through and edit the dates. I'm going to have it lapse on May 10th at midnight. And the final will start on May, well, I'll probably leave it open longer than that. It doesn't really help students to see it ahead of time. I'll probably leave it open longer than that, but the final will start at midnight on, well, what do you guys think? I was going to say Tuesday, but I could make it Monday so that you guys have longer. So that way you guys have longer. Maybe I can even make it for Friday night. Friday night, I don't know when we can do. Saturday night. Maybe I'll make it available Saturday. And it's going to be available through Sunday, May 15th at midnight. So you'll have a while to do it. It's only a 2-hour test. Let's see a chat topic. Saturday's good. It gives you like a weekend and then another half of another weekend. I'll get it up when I can on Saturday. I'm doing stuff Friday night with friends that are coming out of town. But it's very similar to this practice final. I am in one of the modules. I have it set up in student view, so it's kind of like what you'll see. I think phones have a similar view to this, where your to-do list is at the bottom, wherever your to-do list is. That is not the correct final exam. I need to edit that. Why? I don't even know why it's showing it. I need to take care of that. That is not the right final. All right, I'll do that as soon as this lecture is over. So practice final, let's take a look at what you're looking at. This is what you can expect. We will have 10 questions. And they are related to what we've done, everything after the midterm. So since the midterm, we have learned, or post-midterm, we have learned about confidence intervals, which I'm going to abbreviate CI. And we have done a confidence interval based on proportions and one based on means. And for each scenario, we get a lower limit, I'll call that LL, or a lower, and then an upper limit. And I'll call that UL. That's a range around the numbers that we're looking at. So when you get to a problem that asks for a confidence interval, I am asking for a statement of confidence. That goes something like this. Example. We are blank % confident that the true proportion / mean, whichever one we're looking at, for insert details here, is between so-and-so and so-and-so. Here goes our confidence interval, like Commonly, we do 95%, but I'm not saying that that's what they're all going to be. This is where the lower limit goes, and this is where the upper limit goes. And I'll give an example with some of the questions we'll see here. Now, you have an option for what you can put here for proportions, the proportion ones. You can either put the proportion or percentage. So we'll get to an example in a second with confidence intervals. I'll show you one of those in a second from the actual practice. And then for the mean, the numbers should stay the same exactly as is. There's no editing. Make sure to use the units. If it's regarding inches, say so-and-so inches and so-and-so inches. So maybe I'll put here percentage slash units, percentage slash units, something you can put afterwards. I'll give you a chance to write that down. So that's 2 of the 8 questions. Everything is in Canvas. I'm going to give you all the values. So far this semester, you've been doing the homework and you had to go to StatCrunch to get the values. And seeing as how StatCrunch is likely not what you're going to be using when you leave here, if you go into a field where you use statistics, it's unlikely your workplace is going to use StatCrunch, although it might. It's a valid program. The point is that this isn't a class on the software, it's on a class of whether or not you understand introduction to statistics. So that's what I'm going to test you on. Do you know what confidence intervals are? Do you know how to write a statement of confidence? Does it make sense? Is it coherent? All right, if you need that up longer, let me know and I'll put it back. Otherwise, I will talk about the other 8 topics. Okay, the other things we've studied since the midterm are hypothesis tests. For one sample, we've done both proportion and we've done mean. And what was different for every hypothesis test was H0 and HA. So for proportions, let's see this. H0 was always a statement of equality. We had P equals some value. And then for HA, we had P was either not equal, it was less than, or it was greater than that same value. And the mean was set up the same. Mu equals value. Mu does not equal, mu is less than, mu is greater than that same value. I am going to abbreviate the proportion with one sample as 1p, and I'm going to do the mean as 1 mu, or 1 dash mu. Because if you're typing it, you want to type it, that's an one dash mu is something easy to do. Then we had the 2-sample test. If I'm going too fast, tell me to slow down. We had 3 categories here. We'll do an H naught and HA for each of them. We had the proportion. We had the paired means test. And we had the independent means test. So here we had 2 categories, 2 groups. So we need to label them. Label group 1 and group 2. And then our H naught for our proportions test was P1 minus P2 equals 0. And when you're doing statistics, normally this can change. If you want to do something that, like, say it's more than just different. And then HA was again P1 minus P2. We either had not equal to, less than, or greater than that same value. For the paired means, they like to call it mu/d or mu difference. The mu d was mu1 minus mu2. And then we have either not equal to, greater than, or less than that same value. It's very important that you label the groups, because this HA changes depending on which one you have labeled group 1 and group 2. Okay. And the independent means was the same thing. They didn't use mu d, they just used mu1 minus mu2, but it's still the same idea. They subtracted them. And we had to easily choose not equal to, greater than, or less than that same value. And I will abbreviate this 2P. I will call this paired. And I'll call this 2 mu or 2 mu. This is a recap of what we've done, and then I'll show you how it applies to our final in a second. Any questions on this one? I got the 3 or more samples next. Which I can probably get away with here. 3+ samples. I'll do this one group at a time. The first one is goodness of fit. And this was like the M&M with percentages problem. And the idea here was, how well does the sample data fit the proportions in H naught? or in the, I want to say H naught, in the given scenario or the pre-existing scenario. So for H naught, all proportions match their expected values. Not necessarily equal to each other, but they just match the expected values. Like the M&M colors don't come in equal proportions. Blue is the most common color nowadays. Percentages of M&M colors have changed over the years. How's that for fun information? There's your useless trivia fact for the day. Then HA is at least one group doesn't match. The expected proportion. All right. Leave that up another 30 seconds. All right, if you need it longer, let me know. All right, so that was goodness of fit. What else do we have with the three samples? We had the chi-square test for independence. Independence, also called the homogeneity of proportions test. This one's easiest to label as chi-square. And you could put chi with the square symbol. The symbol for chi is a crazy looking X with the 2 on it. 2 is for square. All of those are a good way to flag that as what it is. This was the one that we've done contingency tables for. Which means we need data for different groups. And what we checked here was, were the rows independent of the columns? Were row categories independent of the column categories? Columns are usually the populations, and the rows were usually options. And what H naught here was rows and columns are independent. Which means one doesn't influence the other. And HA is rows and columns are not independent. And finally, what do we have? We had our ANOVA test, the one-way test. This one was is 3 or more means. And I think just calling it ANOVA is good enough for what I'm going to ask you. H naught here is mu1 equals mu2 equals mu3 equals mu k, however many groups there are for k groups. And then HA is at least one mean is different. All right. Everyone ready to talk about the final? Those are our groupings. Let's talk about what we do with all that. If you need this up, let me know. I'll put it back up. We can see the instructions here. You have 2.5 hours to complete this exam. Complete each of the following. So for the final, there are 10 problems in Canvas. Two questions are confidence interval. And I already mentioned how to answer that. But it tells you here. Explain what this information tells us with a statement of confidence. I will provide you with the question. AKA word problem. And the lower limit / upper limit values. And we'll answer it like we said earlier. We're so-and-so % confident that the true proportion, if it's a proportion confidence interval, or the true mean, if it's a means confidence interval, for so-and-so problem lies between this value and this value. The other 8 questions, and there is 1 each for each of the hypothesis tests. Again, I will provide you with the word problem. The test statistic and p-value from StatCrunch. Okay. And what I want from you, you will provide as your answer what type of hypothesis test is being conducted? And you don't need a sentence for this. You could say a 1p test, a 1 means test, a 2 proportion test, a paired test, or a 2 mean test. We've looked at the goodness of fit. We've done chi-square or chi-squared. And we've done ANOVA. So all you gotta do is put one of those categories. Tell me which one of those 8 categories applies. There is only one question for each category. So if you make a list of these and start crossing them off as you use them, when you get near the end, you'll know which it is. Some of them are a little tricky. Like paired test and 2 means test can be confusing. So like if you get one and then you get to the other one and you're not sure which is which, try to make a decision there. Paired tests have to have the same n values. That's a key factor for paired tests, which makes them different. N1 has to equal N2. It must. For the N or the 2 mean test, N1 doesn't have to equal N2, but it can. So if N1 equals N2, it could be either. If N1 doesn't equal N2, it's got to be the two means test if they're asking about the mean. Okay, so that's one thing you'll give me. You'll give me what type of test was conducted, 8 different options. Let me leave that up for another 20 seconds. Okay. That's part A. You provide that. B, you need to tell me what H naught and HA are. Like I should see somewhere on your paper, H naught, HA, and then what the two things are. And we went over the list. The list of options was done previously. But it's based entirely on what test you chose for part A. C, it's a good idea, although not required. This part's optional, but recommended. Show me your decision-making process. I.e., is p-value less than alpha? If it is, we reject H naught and we support HA in our statement. If P is greater than or equal to alpha, we do not reject H naught. We do not support HA. And this one is, there is not enough evidence. So the three nots go together. The first one, there is sufficient evidence. So comparing p-value and alpha and putting which symbol is correctly in there tells me your decision-making process. The reason why I recommend you put it there is if you're wrong in part D, you're going to lose a lot of points because that's what this is all about. But if your part D matches your part C, but your part C was wrong, if your D matches your C, your decision-making process, you'll still get some decent credit for that. It just means you screwed up part C. If I don't know what you chose, why you chose your conclusion, I have to put all the points on it. Then the D category is your, which is not optional, your statement of conclusion. which is always about HA. There is / is not sufficient evidence to support the claim that, and then here you want to paraphrase HA. So you'll either have there is sufficient evidence to support the claim, or there is insufficient evidence or not sufficient evidence. There is not enough evidence to support the claim about HA. And that's how it's going to go. And I'll give you an example of each. Well, we'll go through some of the examples. All right, any questions? Okay. I am going to hit stop recording right now, and then I'm going to start a new recording. What I just gave you will be up the entire test. The following part is me walking through the practice final, and I'm going to take that down when the actual final starts. That will no longer be on YouTube because I'm not going to leave a video up showing you how to do the entire final while you're taking the final. That would be stupid on my behalf. So let's stop recording.